In this lab, we are going to implement a binary search tree. Binary search tree is a special case of a binary tree, so let's review what binary tree is first. It's noted that B tree is a not binary tree, so B tree is another tree, some advanced topics there. So we are going to study binary search tree only. So in computer science, binary tree is a tree data structure which each node has at the most two children, so zero children, one child only, or two children, so at the most two. Based on that, we have the term binary. Binary means two. So where the left one is referred as left child and the right one is right child. So if you define binary tree recursive manner, then we can use a tuple that the center here we have a singleton called the node, and then it has a left and right, and left and right are again recursively binary trees, or it could be empty. So here is a graphical representation of a binary tree. So let's verify whether it's a binary tree according to its definition. So according to the definition, binary tree has a node, and then it has a left binary tree and right binary tree. That's the definition. So left and the right itself is a recursively binary tree. So here we have a node. The node is called the root of the binary tree. Root, you have a root node, and then it's at the left binary tree and then right binary tree. So the first, the overall looking is good. In the left binary tree, it's a recursively, so left one should be itself binary tree. So we find the root, and then it has a left subtree and right subtree. And as we further go to the left subtree t, so this is a root of this tree, and then it has a empty left and an empty right. So empty set is also binary tree, so it satisfies. So if we investigate further, this was a right of 7, and this is again binary tree because here we have a root and it has a left and right. If you go further to the left, so this is root and then it has a empty left tree and an empty right tree and so on. So for each case, you can just examine that the whole graph satisfies a binary tree definition. So here, our ultimate goal is a binary search tree. So binary search tree is a special case of a binary tree where the data stored in the binary tree has a certain order. So here, as a graphical representation again, what you got is a binary tree, but binary search tree. To be a binary search tree, the requirements, additional requirements is that the value at the node should be greater than all the values on the left subtree and smaller than all the values in the right subtree. That is the requirements. The ordering of data in the node is the requirement. So here we have a node. The left subtree is here, right subtree is here. So the value at the node should be greater than any value on the left subtree. So as you quickly examine that, that's true. The value at the node should be less than any value on the right subtree. So that is satisfied. We recursively apply this rule for any node, for each node. So if you take a look at this node, it has a left subtree and right subtree like that. So at this node with a 3, all the values on the left subtree should be smaller. All the values on the right subtree should be larger. So that is satisfied. Within this tree, we can also verify that by picking up 6, all the values on the left subtree, all the values on the right subtree, the property requirement is satisfied. And keep going on. So pick up just any node. all the values on the left subtree, there's no left subtree, but all the values on the right subtree is greater than the one in the node. So for each node, if this requirement is satisfied, then we call it as a binary search tree. So in acronym, we use a BST for binary search tree.